Okay, I would like to parameterize the solid model that you see here. It is basically a ring which has got a number of holes on it, and the parameters that you specify is going to be the big radius RB, the small radius RS, the radius of the hole, and the number of holes. Okay, so RB, RS, and R are all parameters of type length, and N, the number of holes, does not have units. When you say I have 5 brothers, 5 does not have unit. When you say I ate 6 bananas, the number 6 does not have any units. And in CATIA, things that do not have any units is called parameter of type real. All right, so let's go ahead and do that. Let's make a part. On a convenient plane, draw your circle. So let's I'll draw a big circle here and draw a smaller one. Dimension these, dimension this, and dimension the other one. Exit, pad it. On this face, sketch. Let's draw a little circle. There we are. And for example, dimension it. Exit and make a pocket. Good. Now let's make a circular pattern. Circular pattern right there. See this? See this? Circular pattern. Now read it carefully. What we want is complete crown, and the number of it, let's make it I don't know, maybe 6, and the reference element is that face, and what we want to pattern is that pocket, or the pocket, and we say okay. So here is actually the part that we made. Now let's go and create our parameters. So f of x, first of all, we need 3 parameters of type length. So let me change this thing to length. First one, we called it RB, small radius. Now I'm going to make this thing 1. Another one, RS. This is the other one was a big radius, RS. So let's make this thing 0.5. Another one. The radius of the circle, the little hole, which obviously must be so that it fits between RB and RS. So I'll make R, and the value of it I'll make maybe 0.1. And finally apply, and finally we need a parameter which is of type real. So let's see if we can find real here, the very first one, and we're going to call it big N, and we make it I don't know, maybe 4. Right now I think it's 5 or 6, but we're going to make it 4 now, and that's it, and we say okay. So you can see the parameters appear right here. Oh, one thing I forgot, the R didn't appear there, so that's alright. So we go to f of x, make a parameter of type length. Another cancel, not string, I want length. Where's the length? Right there. And I think we called it R. Apply. Okay, good. All right, so now let's go and create our equations. F of x, click on the screen, All right, let's see now. First of all, this one is your RS. So add the formula. Sorry, RB. This is the big radius. Add the formula R big. This one is the small radius. Add the formula equal to RS. And now notice that R, the radius of the pocket, does not appear here. However, if I go and select the pocket from the screen or from the tree, I get the dimension popping up. So this, add the formula equal to R. All right. And finally, you have to look for the thing that gives you the number of the pattern. So let's see now. Where would the pattern be? The pattern, can you do it from the tree? If you go here, select it from the tree, or probably from there. There is the number of the current number, and I want to say the formula equal to n. And then you say OK. Out of bound. Let's see now. Lots of mistakes there. Oh, this is angular number. So let's actually, we created the formula here. Let's delete this formula. So delete this formula so that we don't run into the issue. Let's see what happened. So click on the circular pattern and see whether you can find actually where is the number. That was this, right? The circular pattern. Right now, okay, so how many you have? 1, 2, 3, 4, 5, 6. This actually was 6. Okay, let's see what we got here. Let me update this first of all. We got a problem. Let's see now what happened. Something I accidentally screwed up. So let me see. Circle number. Angular number is 6. That's what I want to say. Add the formula equal to, I think that should be n. Oh, look, accidentally the n that I created, see that? It says 4-inch. That's what the problem is. Cancel. Actually, that's good. We get to practice something here. So rename formula, rename parameter. I want to delete this. This should have been real. Accidentally, I changed. So let me delete this. Delete this parameter. Delete this parameter. Are you sure? Yes. Make another one. So we want a parameter of type real there, and new parameter, and this is going to be n. And the number is going to be 4. All right, apply, and okay, let's see now. Something happened here. Why is this thing? Well, that's okay. That's fine. That's fine. Let's find out. Okay. So f of x. Click on the circular pattern. This is the angular number. The formula equal to n. Apply. The specified profile isn't valid for feature u. I'm not sure why. So okay, so let's try it. Let's try it again. What's the issue here? Rename parameters. This is all good. N. Yeah. 90 degrees. Angular space is 90 degrees. And well, let's find out. Okay, so update. The specified profile is invalid for feature you want to create. I'm not sure why. Pocket. You know what? Let's exit. Let me check my dimensions here. RB, 1 inch. Let me make this thing bigger, 2. See, there's a problem with that pocket. So, what's the value of R? Oh, 0. That's what the problem was. Okay. You see, when I was creating it and saying this is equal to R, inadvertently I didn't specify a good value. So I'm going to make this thing 0.1. All right. Okay, so let's go and clean it up. So RB 2, RS 0.5. Now obviously R cannot be equal to it should be okay. 8. Something is not right. There's no message here. Let's check our sketches. This is, that's fine. Oh yeah. Okay, I know what the problem is. It's this sketch, which is outside there. You see that? All right, I see. So this is a good place to fix this thing. So here's what I'm going to do. Let me draw a circle right there. All right, and let me dimension this. Okay, and why don't we do the following? Turn this thing into construction. Okay, and let's say that this center, the center of this small circle, we want it to be always on that. So we select that point, control that circle, and we make it a coincident. All right, good, very good. Now, this circle, this radius, let's make it exactly halfway between RB and RS. So I exit that. All right. So f of x. This is actually good exercise for what falling apart, and we have to clean it up. So let's see now. We want the circle that we drew in this sketch right there. This, add a formula equal to R1/2 or RB plus RS divided by 2. Very good. Okay, apply. All right, let's see now. Okay, so let's change the first of all the number of pattern into 60. There. Now, R is the radius of that circle. So make it smaller, 0.05. I have to be careful. If I make it too big, they're going to intersect with each other. There we are. I can even make it bigger, but then there may be a problem. Let's try it. For example, if I make it, how about 0.8? Let's see what happens. Oh, 0.7. Oh yeah, let's put it back. 0.5. All right, still too big. 0.05. Good. RB, the big radius. So let's make that thing 3. There we are. RS. Let's make it 1 or 2. Looks like that. R. Well, let's reduce the number of circles. Let's make it 6. And let's take the R and make it bigger. Now let's make it 0.2. See what happens. There. You got the picture? All right. I'm glad that things didn't work out, so that we had to go and do some detective work and try to